Welcome, Mr. Yang, again to our show to introduce more about this planetary defense system and planetary defense test. It is a very historic moment because for the first time ever, human beings send a bus size of the spaceship to move forward asteroid, to move to off the orbit. So it's a very historic moment. We know that asteroid defense plane is very important because more and more evidence show that dinosaurs are extincted because of asteroids' impacts. And now we know that there's a certain rate because if the asteroid is big enough to impact the Earth, it will cause another extinction of the civilization. So this plan is supposed to be very important, but we seem to lack of the experience and the knowledge of the importance of the asteroid defense plan. So could you please introduce a little bit more about the importance of it and why should we carry out such tests in the future?
Well, you know that there are so many asteroids in the solar system.
Yes.
But those which has a possibility to threat the safety of the Earth, of human being, yes, we call them the near-Earth objects, yes. NEO. Yes. So this is near-Earth objects. The threatening from the near-Earth objects, we should concern that, and also we consider about the damage it causes. So you see, if the asteroid, the size or the diameter of the asteroid is bigger or larger than 10 kilometers, if it impact on the Earth, it will cause what you mentioned, the extinction of dinosaurs. This kind of disaster may cause damage and also annihilation of many species, including the human being.
Yes.
Absolutely. This kind of impact must be avoided. And the second level will be the impact by an asteroid with a size between 1 kilometer to 10 kilometer. You see, this kind of impact can cause disaster on global level. All the people on the ground will suffer from this kind of impact, but not necessarily to extinct all the species. Although it is also very serious, for instance, maybe it causes a very giant tsunami or other earthquake or so on. And also the dust may go into the atmosphere and block the sunlight and cause winter-like climate. So maybe many of the crops will die, and also we will lacking of food. So that is the disaster it caused, but not necessarily to be many years, because as I mentioned, the 10-kilometer level asteroid may cause the dust to go into the atmosphere and block the sun for many years. So absolutely bigger animals such as human beings and other big animals all will be annihilated by this kind of impact. But for what I mentioned, the 1 kilometer to 10 kilometer size, maybe several months, maybe even less. So this kind of impact will not destroy all human beings, but also a global level, a disaster on global level. And for the size between 100 meter to 1 kilometer, this kind of asteroid will cause the damage of a region. It is also very serious. But you know that we've already discovered, that the larger the asteroid is, the number is less, and the smaller is, there is numerous these kind of objects. You know that for objects larger than 1 kilometer or 10 kilometer, it is easier for human beings to discover that. Until now, based on the observation of the ground-based telescopes and also on those spaceborne telescopes such as Hubble and other space telescopes, we believe that we've already found almost all the asteroids bigger than 1 kilometer. And also, based on the precise prediction of the orbit of these kind of near-Earth objects, we have a conclusion that in this century and even in the next century, there is no possibility that these kind of objects will threaten the safety of the human being.
Okay, I can sleep tight tonight.
you can, and your son.
Yes.
And your kids.
Yes.
Even your grandson.
Okay.
But good to know that. But the problem, you see, that for those between the size of 100 meter to 10 kilometer, yes, you know that these asteroids is big enough to cause a very serious disaster, but it's smaller than what we mentioned last. So it is relatively difficult for human beings to observe and discover these kind of objects. So that's a problem. You see that although we believe that we've already found most of them, but maybe there are exceptions.
Yes.
So, so the major task of human being now is to discover and find the rest of those objects bigger than 100 meter and 1 kilometer. And for the for those size less than 100 meters, so there are more of these asteroids, but the threat is also smaller. Not so serious. So that's the whole situation you mentioned. So you know that although we've already found that maybe there is no any dangerous situation that we must facing during this century, but there are also another exception. You see, we talk about the near-Earth objects,
Yes.
but there is another class, a large class of space objects, comets. You see, you know the famous, for instance, the Halley comets and other comets. You know that these comets orbiting the sun with a quite very different orbit comparing with the near-Earth objects or the asteroids. You know that the asteroids, its orbit usually is similar to the Earth because it has a cross with the Earth. That crosses the thread. But you know that the orbit of the comets is very long and very thin. So usually they visited the inner solar system or the vicinity of the Earth maybe several centuries or even several thousand years. So you cannot find it because it is still far away from the Earth. When it goes into the inner solar system, usually you don't have much time to avoid any disaster if it has a possibility to hit the Earth. So that's a situation we must face. And also, it's although it's maybe the possibility is even smaller than the asteroids, but it is also a very serious threat to the human being. And so, what we mentioned, the importance of the test in recent days is that we have all kinds of measures to avoid the damage of this kind of impact. There are several of them. One is to put a nuclear weapon on this asteroid and ignite this nuclear weapon, and maybe it will break into pieces.
Yeah, but there's another controversy theory between this. There are so many different plans about if we discover a potential, like with high risk of the planetary, it will impact the Earth. But how do we deal with it? The plan A is what you mentioned. We use nuclear weapons to make it to pieces. But Rusty, another scientist and the former astronaut of NASA, she disagrees with this plan because if we to explode it to many debris, it will firstly, the accuracy of the target is a problem, and secondly, it will fall to different pieces. For example, it will potentially hit one city, but if you explode it to different pieces, it will potentially hit other cities, and it's unfair. It's politically have some problems. So there are different kinds of plans about that.
So the effect on exploding an asteroid, so it will be even more dangerous or less dangerous. Still, we are quarreling about this. Yeah. So there is no any conclusion now. The problem comes from that the energy of the nuclear weapon may not be necessarily act on the asteroid for 100%. So that is one reason. And also, another problem comes from the formation of the asteroid. Maybe it will be broken into pieces, maybe not. And absolutely, in all these cases, usually the orbit of the asteroid cannot be changed very remarkably. So as you mentioned, maybe all these pieces, although smaller pieces will be much more safer than the bigger one, but there will be more chances to hit the Earth. So that's a problem of using the nuclear weapons. So this is what we mentioned. Still, we are quarreling about this plan A. The plan B is to put an engine on the asteroid. So this is very interesting. You can see this kind of science fiction movie before, I believe. So, but
Obama mentioned that. Sorry, Obama mentioned that before. He mentioned that by 2035, in theory, U.S. will send astronauts to the asteroid and put some engines insert it into the asteroid and to make him move out of the orbit. So that's another plan to send
Exactly.
men onto
What
the
you mentioned
asteroid.
is what you mentioned is called the asteroid redirection mission.
Yes.
Pity that it has already been cancelled. So the technology used on this plan, we have so we must confirm that we found the threatening of the asteroid as early as possible. Only in this case we can use this plan B. You know that for any kind of engines, the thrust is relatively small. So if we use these engines, you must do this as early as possible to change it out possible.
How to put the engine on the asteroid?
You see that we must have a spacecraft first, and I believe that in the future, for this kind of spacecraft, it must be a nuclear power driven spacecraft with nuclear thermal engines or nuclear electric engines. So these kind of engines is quite different from the chemical engines because the efficiency or the what we call the specific impulse is much higher than the conventional chemical engines. And we use these kind of engines, we can bring a very huge spacecraft, maybe several hundred tons to outer space and change its orbit remarkably and finally rendezvous with the asteroid and then soft landing on the asteroid. Because you know that if we don't have much energy, maybe the relative speed, the combined speed between the spacecraft and the asteroid will be very high. So if you meet that asteroid, you yourself will be damaged. So if you want to have a soft landing, it must be have the same speed. So the velocity or the capability we changing the speed of the spacecraft must be very high. That is reason why we use a very high efficiency nuclear thermal or nuclear electric engines. And use these kind of engines, we can soft land on the asteroid. And then we have two measures. One is to still use the engines and use the fuel we brought on the spacecraft to propel the asteroid to change its orbit very, very slowly. No, not like this mission.
Okay.
Because this happened gradually. Another choice is to also use the nuclear energy, but with a different manner. We dig on the asteroids and throw the rock we digged to the outer space. So you know that we put that in a very high speed, and
with
the
an
asteroid
extra
itself
force.
will change its speed. So this is a more efficient one because with this measure, we will not necessarily to bring any more propellant to our spacecraft. We just need energy to use the nuclear power. So this, I believe, this will be a better way. So what we mentioned, the Plan B is very efficient for huge asteroids. Those with a very big size. So this will be, but you know that this is also the most complicated case or the most challenging technology. Whether we can do it or not, we still don't have the answer.
What are the most challenging points during the whole process?
The whole process, you see that we need a very huge spacecraft. Because you know that we must brought a nuclear reactor into the outer space. Until now, although you know that during the last century, maybe in 1970s and in 1980s, the former Soviet Union launched many nuclear reactors into outer space. But you know that it is very dangerous. And until now, the human being has not solved the problem of the safety of these nuclear reactors. Although you know that in the future, not only this kind of interplanetary defense, but also the other explorations, we need the nuclear reactors, especially those with very powerful output for several million watts of output. We need these kind of huge nuclear reactors. But still, until now, we cannot ensure that it is safe enough. So this is one challenge. Another challenge comes from what I mentioned, the nuclear thermal engines and nuclear electric engines. It is still a very difficult technology to achieve. So we need this kind of test in the future. And also what I mentioned, the soft landing on the asteroid and also the changing its orbit is another also very difficult. So you are very correct. It is challenging in all of its process. And another problem comes from the quarreling. If we change its orbit, maybe it will be worse. Maybe before we changing that, it will not. Although there are a certain possibility, but maybe it will not impact on the Earth, and if we change that, it impact. So that is also one of the problem. So that is also, we must have a very careful calculation and prediction of its orbit. But until now, the longer the time is, the more difficult we predict very precisely. So that is also very difficult. That is plan B. And plan C is what we talked today, is based on the impact, on the high-speed impact. So that's the impact today we talked is not the first one. Have you watched the movie in 2005, The Deep Impact?
No, but I did watch the Hollywood blockbuster Don't Look Up. It
Yeah,
also
exactly.
mentioned
Similar.
the impact, similar
that's
series.
the Deep Impact is a very good movie.
Okay.
It's described
I'll
about
make it
the
on my
story
list.
about the a comet will impact on the Earth, and a team go to outer space and to rescue the whole human being. But there is a space mission called Deep Impact in 2005. Well, this mission is very similar with the mission we talked today, with the DART mission today. But the Deep Impact is for a different purpose. You know that the DART mission is for the demonstration or technology demonstration to save human beings. But the Deep Impact mission is purely for scientific research. So the spacecraft is called the Deep Impact, and the target is called the Tempel Comet. The Tempel Comet, that in 2005, the Deep Impact spacecraft released an impactor. The impactor rendezvous its orbit and impact on the comet. It is very interesting, that the impactor is almost purely made of copper.
Copper.
Yes, exactly. The reason, that it comes from its purpose. As I mentioned, that the purpose of this mission is to perform scientific research. The impactor will hit the comet and then splash all kinds of dust. Yeah. And that on the Deep Impact spacecraft itself, there are all kinds of cameras. It will watch the dust, and through the spectrum of the information, it can get the composition and all kinds of other necessary information about this comet. So that is the first impact mission the human beings have conducted before. So this DART mission is not the first one. But for this DART, or the double asteroids redirection test mission, is purely different purposes. For this mission, it do not have any scientific research purpose. So the only goal of this mission is to test the technology of what we discussed, the Plan C. The Plan C. This to changing or the deflection of the orbit of the asteroids is based on the high-speed impact, and then the exchange of what we call the momentum of the asteroids and the spacecraft, and we can change its speed. Although that even for very small asteroids, the mass is much more greater than the spacecraft. For instance, the impact happened this time. It's called dinosaurs. It is one part of the twin or the binary asteroid. So its mother asteroid is called the dinasours. The dinasours is composed of these two objects. That the size of the dinasours is the diameter is about 780 meters. Yeah, exactly. And the size of the dinosaurs is about 180 meters. So the total mass of this system is more than 5 billion kilograms. I think it's maybe 5,000 billion kilograms. And also the mass of this dinosaurs is greater than maybe 5 million ton. So it's very big. That the spacecraft is only several hundred kilograms. Yes, exactly. So it's much smaller, and it can only change the speed in a very straight level. So if we want to change change the orbit of those objects, threatening the safety of the Earth, we need a bigger one. But this time, to demonstrate and verify the technology is already good enough. If we and also for this, what I mentioned, this Plan C, in the most ideal place to using this technology is that the asteroid is not very big, and also it's already very late if we have when we found it has a possibility to impact the Earth. So that is the case we use this technology on this Plan C, and the impact technology is not a very difficult one, because you know that, as we mentioned, the human being has conducted that in 2005. So the challenge did not come from the impact itself. It's already a practical technology, and this technology, but it is necessary we test this technology and test if it is efficient enough to protect the Earth.
Yeah, if I don't know if I understand it correctly, that the Plan B and Plan C. The Plan B is that you use the nuclear engine driven of the spacecraft, spaceship to make it explode. So on this asteroid,
not explode, but use the engine to change its speed gradually. What you mentioned, the explode is based on the nuclear weapons on Plan A. So on Plan B, we use the engines. So you know that with the engines, we can change the. You can recognize when the spacecraft and the asteroid combine together or soft landed on the asteroid, it combined one giant spacecraft. And we use the engine to change its velocity.
Okay, so that's some very brilliant ideas about it. And there are so many difficulties ahead of those steps, because we know that the most famous case about asteroid impact on Earth is back to 2013, I believe, in Russia. And in this case, scientists are blind to those asteroid impacts because as you mentioned, there are some big asteroids, and we can use so many observation measures to see them. But for others, for the case back in 2013 in Russia, the sun has blinded us to see them. The ability to see the asteroid is another problem, it's another challenge. And how do we solve them? Because in 2013, we cannot see them because the sunlight has blinded us from seeing it. So how do we solve problems like that? It's the first step between all of those measures.
What you mentioned is really a very serious problem. You see that the disaster you mentioned in 2013 is, actually speaking, it is a small asteroid. It is small, but although it is smaller, maybe less than 100 meters, but it also the power of this asteroid is greater than maybe several hundred nuclear weapons used in the Second World War. So it also hurt many people in that disaster. Exactly. So almost 1 century before, also in Russia, in Siberia, there is another very giant explosion, also caused from an asteroid. So that's even bigger than this one, but it in Siberia. Exactly. Although maybe you know that, although maybe no many people died from this explosion, but it's really, the power is much greater than the 2013 one. You see that as I mentioned, the smaller the asteroid is, the more difficult we find it, and this is a very small one. So the early warning is a very important and a very necessary technology we must very urgently to master. And as you mentioned, you know that for bigger asteroids, for instance, like those one bigger than 100 meters, it's relative for the optical telescope to observe. And also, the United States have a system called Atlas. The Atlas system have two telescopes, maybe in Hawaii, and the other two in South Africa and also in South America, I believe. So with these telescopes, the U.S. can monitor all kinds of objects in outer space and give some kind of a certain level of early warning. But you see that for in a certain case, you know that we talked about using the optical telescope. So the sunlight is really a very good condition, very important condition. So if the angle between the sunlight, the viewer, as the asteroids cannot meet with the basic requirement, even it is very close to the Earth, we cannot find it. So I believe that one solution is to send a relatively big spaceborne telescope, and it must be sent to a distance very far from this. From the Earth. For instance, maybe on the L2 Lagrange point or libration point, maybe 1.5 million kilometers from the Earth, or even far from the Earth with the L4 or L5 Lagrange point. With this spacecraft, you know that the viewing angle or the line of sight to the target will be quite different from the viewer on the Earth. So I believe this will solve the problem. But you know, until now, the largest optical telescope of human being is James Webb Space Telescope, and the diameter or the aperture of his main mirror is only 6.5 meters, and the aperture of the Hubble Space Telescope is only 2.4 meters. Maybe already it's big enough, but it is quite difficult to send these kind of large spacecraft into the deeper space. So also, you know that these kind of space program usually need the investment more than $1 billion. So that is the reason why until now we don't have these kind of plans. So I believe to solve the problem you mentioned, we must send a spacecraft, a huge spaceborne telescope to a distance far from the Earth.
Are these plans underway yet?
Until now, as I know, the space-capable nations, including those advanced countries, do not have these plans. But of course, there are preliminary studies, and the scientists and scholars are studying the possibility to using this technology. But from my view, that the technology of this the spaceborne telescope is already very practical. The problems come from the investment, the budget. So that is the reason these scientists and engineers from all over the world should do our efforts to promote these kind of plans. It should be international cooperation. You know, the importance of the international cooperation is to reduce the threshold for the decision makers, for those from the government to choose this kind of plan. And also we need the coordination to reduce the cost. So that is very critical for us to promote these kind of plans.
Yes. Okay, so let's move forward to the specific plan, the DART plan. Could you please describe the full process of how does it work to go out there and impact the asteroid Dimorphos?
Okay, so the DART spacecraft the spacecraft itself is like a box. And the total mass, the lift out, is like a box. Okay. So the total mass of this box is about 610 kilograms. So it's not a very big spacecraft. And as I mentioned, it do not have any scientific research payload. And the major payload is a guidance camera. The guidance camera. You know that it must gather images of the asteroids and then adjust its trajectory to hit on the asteroid. And the major payload, as I mentioned, is called Draco. It is a small telescope with an aperture of its main mirror about 20 centimeters. So this is a small telescope. With this small telescope, and it is very interesting, you know that the human being has already had a Pluto mission, the New Horizon. The New Horizon is the only spacecraft that has visited the Pluto system before. You know that this Draco, what I mentioned, this Draco telescope is based on the technology used on the New Horizon, the Pluto mission, and but it is much cheaper. Because you know that mission happened maybe two decades before. Well, this because with the technology's development, the sensor becomes more cheaper and more powerful. In the Pluto mission, the telescope used what we call the CCD sensor. And with this DART mission, it used the CMOS sensors. It is cheaper, and it is a commercial on-the-shelf sensor. But it's much more powerful than the sensor used on the Pluto mission. So although it is cheaper, it is powerful. So it can measure the position of the asteroids very precisely, even from the from a very, very long distance. And you know that the prediction based on the ground telescope of the of the Didymos system is only the accuracy is only 2 kilometers. So you know that is not accurate enough. So that is the reason why it needs this guidance camera. It can ensure that the spacecraft can hit the asteroid. So the whole process comes from the spacecraft is launched by the Falcon 9 launch vehicle. Made Falcon 9 launch vehicle by the rocket. I mean, the carrier rocket is a Falcon 9 launch vehicle made by the SpaceX, and it was launched in Vandenberg, on the western coast of the United States. And it was launched about 9 months before, or 10 months before, from Vandenberg, and then directly launched by the Falcon 9 launch vehicle to the Earth's escape orbit, which means that it reached the second cosmic velocity. And then it go on its way to rendezvous with the Didymus system within 9 months. And during all this process, it's adjusted its orbit several times to ensure its accuracy. And also during this process, it has a flyby of another asteroid and take some pictures of this asteroids. So this is the process. And just before and after it is close enough to the Didymus system, the Draco, I mentioned, the telescope has began to work, and it take images of the 2 asteroids. First, it can only see a light spot on its CMOS, and then it becomes bigger and bigger. Finally, it can distinguish the 2 asteroids, the Didymus and Dimorphos, and then it targeting on the Dimorphos. And then just about 14 days or 15 days before the impact, it just released a CubeSat called Lycia. This Lycia CubeSat is made by the Italian Space Agency. It is a 6U CubeSat, very, very small, and the task of this CubeSat is to monitor the whole impact process. It's quite different from the deep impact mission. We know that during the deep impact mission, the impactor hit on the comet, but the main or the mother spacecraft, the deep impact spacecraft itself, fly by and taking photos. Well, this time it is opposite. The main spacecraft, the DART, hits the asteroid, while the smaller one, the Lycia, conducting the monitoring role. So this is, exactly. But because it is very small, so it don't have the capability to transferring the photos in a very high speed. So it's still transferring the images now, maybe in maybe 1 or 2 weeks. When in the Draco telescope, when the Didymus system, it can distinguish the Didymus and the Dimorphos. It then targeting on the Dimorphos, and then conducting several adjustments based on the rocket engines on the DART spacecraft. It has, actually speaking, it has 2 propulsion systems. One is based on the electric propulsion using Shannon as the propellant. It is an electric propulsion system. The other one is a traditional chemical propulsion system using hydrogen as a propellant. Because the thrust is bigger, so as a final case, it uses the thrusters to adjust its orbit, the trajectory, and then finally hit on the Dimorphos. So that is the whole procedure. And just about 2 to 4 minutes before the impact, the trajectory is already accurate enough. So at this moment, the thruster stopped work. And because you know that when it's hot of working, the attitude of the spacecraft will be more stable, and we can see the images, the quality of the images become better, and we can see even the rocks, the small rocks on the surface of the Dimorphos, and then it transfer when approaching its target, it also transmitting signals to the Earth, transmitting the images it taken by the Draco to the Earth, so we can see the last several pictures it taken, and then hit on the body. We believe that it will form a crater on the surface of Dimorphos, and there are several telescopes on the ground in all countries on the western sphere of the Earth monitoring the whole process. They are also monitoring the impact itself. But it's too different from the Earth. Just at the moment of the impact, it's about 11 million kilometers from the Earth. So we cannot get the details based on the telescope on the ground. So we still depends on the CubeSat, the Lycia CubeSat, to send images back. And maybe several years before, maybe 4 years later, there will be another spacecraft called Hera, made by European Space Agency. It will be launched and approaching the Didymos system and give more details of this impact.
Okay, so it has been several days past since the successful impact of the DART plan. So according to the data sent back, how do you evaluate this mission, and how does the data sent back will help us to evaluate the mission and to help us to improve our capability to defend other asteroids in the future?
Well, the capability you asked is based on the precise measurement of how we changed the orbit of the dimorphos. Yes. So also this is the reason U.S. choose the Didymos system as its target, because you know that the Didymos, it is as you mentioned, is a twin asteroid system. It is very unique, and even before the impact and after impact, the change of orbit, whether it is changed or not, it will not threaten the Earth. So this is a very ideal target for technology demonstration.
Yeah, it is an innocent asteroid.
Exactly.
We use it as a target.
And the more important it is that because the target is a smaller one, and because it is orbiting its mother, Didymos, with a distance about 1 kilometer. So although you know that although the spacecraft, the DART spacecraft, is only several hundred kilograms, it can only change its velocity maybe several millimeter per second. But because it is orbiting its mother, Didymos, so the orbital period will be changed remarkably. And although we cannot measure or watch the detail, get the detail of the impact itself, but on the ground we can use a telescope to measure the difference of its period, its orbital period. It will be changed at least maybe 70 seconds. So it can be very precisely changed, measured. And with the measurement of this orbital period, we can measure how the orbit of the dimorphos is changed, and then we can evaluate how efficient it is. We use this technology, and also prepare for the future potential mission to do this kind of protection mission to the Earth.
Yeah. So how much forces we exactly need to have to make the asteroid to change its orbit from this time of mission of calculation?
Well, you know that we talked about this Plan C, use the impact to change the orbit. So if we want to protect the Earth, that's based on several factors. The first one, most important, how long or how many years do we still have before the impact of the Earth? So this is the most important one. The longer is, the less impact, the less energy we needed. Because with the accumulation of time, the change of velocity will accumulate, and the position of the asteroid will be changed very remarkably. So that is another evidence that how important the early warning it is. So this is the first factor, and the second is how big the asteroid is. The bigger it is, the bigger spacecraft we need. So also, you know that even we use a very huge spacecraft, it can only change the speed of the asteroid slightly. Because you know that until now, the largest rocket ever been built by human being is the Saturn V launch vehicle used for the Apollo mission in 1960s and 1970s. Only with this powerful rocket, we can only launch objects about 30 to 60 tons into the deep space. I mean, to meet or rendezvous with the asteroid. So you know that 30 to 40 tons. It is very relatively big spacecraft, but still very small comparing with the size and mass of asteroids. So that is the reason we need to evaluate how big the asteroid is, and to choose what level spacecraft we need for this kind of mission. And the third will be how can we evaluate the effect, as you asked, the change of the orbit itself. And you know that we should talk about the plan of China. You know that although we don't have any concrete plans until now, but we do have very reasonable proposals. You know that in China, some scientists also raised a very interesting and maybe very effective idea. One is to use the rocket itself to hit the asteroid. You know that for any space mission, the end stage of the rocket will go into the same orbit of the spacecraft. For instance, if we launch this DART spacecraft, the end stage or the second stage of the Falcon 9 launch vehicle also entering the same orbit. So if we don't separate the two spacecraft, obviously the mass will be greater. So also utilizing the mass of the end stage will be a good idea. Another idea, exactly, to use its mass. Because with the mass of the spacecraft itself and also the end stage, the mass is exactly the combination, the mass will be greater. So the impact will be more efficient. So this is one idea. Another one is based on hit the asteroid with another asteroid.
You know, the rocket will give a force to the spacecraft. You know, when it detached, it will have a force to make the spacecraft to carry on other missions. But if they're connected, how does it work? I didn't get it.
For any space missions, if the rocket has brought the spacecraft into the correct orbit, then the rocket itself will be separated, because you know that usually on the end stage of a rocket, it do not have solar panels, so it will be out of power and become a dead body. So if we don't separate them, they will be recognized as one spacecraft. So we just only use its mass to be less the mass of the total mass of the spacecraft bigger. So that is the idea.
Yeah, I mean, when it's separated, it gives a counter force to the spaceship so that it can continue to carry out the missions. But if they're not separated, where does that counter force come from?
I know what you mean, but the counter force is very, very small. It can be neglectable. And also, you know, as I mentioned, there are also propulsion system on the spacecraft. It can work longer than the rocket. So we can use that to change its orbit and finally rendezvous with the asteroid. So this is another choice. And the other choice is also raised by the Chinese scientists. As I mentioned, they hit the asteroid with another asteroid. It is the idea combining what we talked the Plan B and Plan C. The idea comes from we launch a spacecraft and then it rendezvous with a small asteroid, land on that, and mount the engine on the asteroid, and then it will recognize that as a very big spacecraft, and then change its orbit to hit another bigger asteroid.
Can we achieve that now with the?
Of course, it will be very, very difficult, but that will be more efficient. You know that, as we have already discussed, even with according to the current technology of human being, even we use Saturn V launch vehicle, we can only launch a spacecraft maybe 30 to 40 ton level. It's still not big enough to change the orbit of a very big asteroid.
We don't have to build this such a big.
So we utilize another asteroid. Maybe it is already in outer space, and maybe it is several million tons. So we rendezvous with these asteroids and land on it. We just utilize its mass. It's already maybe several million tons, and we use that to hit another asteroid with several billion tons, and it will be very efficient.
Yeah, it's a math problem. You have to calculate the orbit, the force you give it, and how does it change its orbit, and you have to calculate the distance, its direction, then it will work.
Exactly. What you mentioned, the calculation will be very, very critical, very, very important for this kind of mission. And also another problem, the energy to change the orbit of the smaller asteroid. We need the energy, and also the thrust must be great enough to change that in a very short time. So that also, although this proposal is very, very hopeful for future to rescue the whole human being if very apocalypse happened to human being, but still it is only a proposal now. We need all kinds of technologies, and maybe we need several steps to demonstrate and verify these kind of technologies for the possibility to prove it is possible.
Yeah, any global cooperations on that aspect between China and international?
Actually speaking, this kind of coordination has already happened on governmental level and also those on non-governmental level. And this kind of cooperation is still in discussing in the in international conventions and other meetings. But still, until now, they do not have concrete plans for this kind of high-level cooperation. You know that the DART mission itself is international cooperation. Italy, US, European Space Agency, Japan, JAXA. So they have already cooperated together. So we hope all countries, all capable nations in the world can cooperate together for this kind of technology demonstration, for the preparation of rescue the whole human being in the future.
Yeah, I have to ask, does similar asteroid defense plans stand a very high position, very highlighted by the countries, different countries' government, or because we know that we have some deep space exploration will pay a much more contributions to our nation's strategy. But does this such asteroid defense plan are highlighted by the local governments?
Well, that at least until now, the priority of this mission still is very low, because that the deep space exploration, the most highest priority missions is to study the history of the solar system. So, including China, that in the future we will have what we call the Tianwen-2 mission. The Tianwen-2 mission is the asteroid exploration mission with two major goals. One is to bring the sample back from the asteroid back to the Earth from near-Earth objects, and then its orbiter will maneuver to the main asteroid belt. It's even farther from the Earth, and then conducting another research. So the asteroid mission of China has two major goals, different from other countries. And that the achievements from other countries, that Japan has already conducted two Hayabusa missions, or both brought the sample from the asteroids before, and also the OSIRIS-REx mission from US is already get the sample and is already on its way back to the Earth. And also there are other missions. You see that in the 1980s, when the Halley comet come back to the Earth, the European Space Agency launched the Giotto mission, and the former Soviet Union launched the Vega 1 and Vega 2 missions to the Halley comet. And also there are other missions, for instance, such as the Rosetta mission, Rosetta and Philae mission to the 67P comet, conducted by the European Space Agency. Also a cooperation with with Japan and other countries, and also other all kinds of these kind of asteroid missions. That the asteroids have a very important feature. It remains some early evidence during the phase of when the solar system was formed in about 4.6 billion years before. Usually, this kind of mission is very, very important for us to have a better understanding of the solar system. Because if you explore the Earth, the Venus, or the Mars, because all these, including the Moon, because these are very giant celestial bodies, so the early evidence may be ruined by the volcanoes or other activities such as the shifting of the crust of itself. So although it is also very important for us, but for the early evidence of the solar system, maybe the asteroid will be a very good choice.
Yes, because many believe that asteroids, the origin of asteroids, are from during the process of formulation of the solar system.
Exactly.
When it's formulated, some other debris come out of it and become asteroids. So observing them is a very key point to
Yes.
to know the origin
Yes,
of it.
you know that's the samples brought back by the Hayabusa mission. Although only a very small amount of samples, but the scientists already find some early evidence of the protein from these samples. So that is a very good example of the evidence of the origin of the life form of the solar system, where it comes from. Very, yeah, exactly. So how you can see how important the exploration is. So as we discussed, the priority of the asteroids detection is not very high, but still. Although you know that we've already mastered most of the important necessary technologies for this kind of mission, but still we are lacking of money. Also we emphasize about the importance of the international cooperation for these kind of purposes.
Yes, yes, and also there's when I watch the live streaming of the DART plan, and there's a countdown, and you can see the very mysterious small white spot becoming bigger and bigger, and then the impact. Then there's a successful impact. I'm very impressive and excited to watch the countdown, the live streaming of this DART plan. So what are the historic, and many see that as a historic moment. So why is it so important? What is the importance of this mission?
Well, you know that besides the impact itself, you know that's the also there are several remarkable features of mission. You can see the video images. You can see the whole live stream. So that is also a very, you know, that's from the viewer of the technicians, that is also very challenging task. You know, that's, as I mentioned, the impact itself that happened 11 million kilometers away from the Earth. And, you know, that transmitting images need a very high gain antenna. And the antenna is used on these. It is the first time this kind of antenna used on the spacecraft. So the antenna is also a very important technology, and is use a lot of energy to transfer these kind of signals or the images to the Earth. And you see that there are another new technologies on this spacecraft. It calls the rolled out solar panels. Also very, although it has already been tested on the International Space Station, but it is the first time used on deep space mission. Also, it provides more than 6.6 kilowatts of electric power, not only supporting the working of the electric propulsion system, but also supporting the huge antenna to transmitting the signals to the Earth. So you can see it is very, very difficult to get the images in real time and transmit them to the Earth in real time.
Yeah. So last two questions. So there's we've just talked about the mission is lack of money, and there's a gold rush clearly in the outer space. Some space cowboys are digging money and digging for a lot of very expensive metals from space. And do you agree with these moves, and how does it work? Is it practical to have some gold rush out of the space?
Well, you know, it's cheating to bring these metals to the Earth, because you know that the cost of launch a spacecraft reaching the asteroids and get the ore from mining the asteroid and then go back to the Earth, the whole cost will be much greater than the same amount of diamond. So it is useless. It is meaningless.
Financially, but I mean, the first step, the first trip may be very with high cost. But if it's commercialized, it will lower the cost of the whole journey, and the cost will be smaller and smaller, and then to cover the cost and to bring more, it's a curve.
You can reduce the cost of space travel maybe to about 10% of the current level, but it is impossible for you to reduce that to 1%. Even you can achieve this 1% level, it is still much more expensive to get the metal, comparing with get the metal from the Earth, because you can find any chemical element on the Earth, comparing those getting from the outer space. But I don't. I mean that it is useless to bring them back to the Earth. But it will be very, very meaningful to utilize the minerals or the ore on the asteroids, in the outer space. The reason comes from, as I mentioned, the Earth is a very big celestial body. to launching a certain kind of cargo into outer space, the cost will be very, very high. But if you can use the mineral or other material resources you got on the asteroid, maybe use that on the asteroid itself, or use that on the moon, maybe it will be much cheaper than brought the same amount of cargo from the Earth. So that is the point. It is meaningful to conducting what we call the on-site resource utilization. So that will be a very, very hopeful field for human beings. Not only the on-site resource utilization of the asteroids, but those resources on the moon and on the Mars. So that is the work that we just do now. You know that we are now on the second wave of the lunar exploration. Just after the first wave ended in 1976 during the Cold War, and the second wave comes beginning from the 1990s from several missions conducted by the US, Japan, and India and China. So these missions we can recognize as the phase that's changing from the exploration to exploitation, because you know that we've already found water on the lunar surface, and we can utilize the water on the lunar surface. So that is why the reason the moon becomes so important for human beings now. Not bring the ore or the mineral from the moon to the Earth. That will be very, very expensive and meaningless. So the point is to utilize the resources on the moon and recognize changing the moon to an outpost of human beings to go further into the solar system. Also, the same thing to the Mars and also the asteroids.
Okay, so today we talk about very systematically about the whole plan, about historic aspect and how does it work technologically. And as we speak, there's another very important event going on here. It is about our country's China's Tianwen plan missions out there. So could you please tell us a little bit more about this orbit transposition plan that's happening right now?
Well, today, you know, that there is a very important step for China's space station program. You know that when the Wentian module come into outer space, it first docked to the front docking port of the Tianhe module. So this is the only choice. And you also know that the final formation of our space station is a T-shaped station. So there is a very, very important step to transfer the position of the Wentian module from the front docking port to the side berthing port. Yes. So this is a very important and very tough task for us, just being conducted very precisely and very perfectly.
More difficult than the docking part.
Exactly. You see that both the Wentian module and the Tianhe module both has a mass more than 20 tons. So bring these two bodies changing its formation is very, very difficult. And we use the position transfer mechanism. You can recognize that the position transfer mechanism as a small robotic arm. The mass is only about 100 kilograms or so it is very small, and changing the position of two huge spacecraft, it will be very dangerous, because even a very slight disturbance may cause the broken of this arm. So that is the reason we do this carefully and conducted that within 1 hour. And then we must consider about the attitude, consider the disturbance of the gravitational field of the Earth, and also consider about the influence of the aerodynamic drag of the upper atmosphere, and all kinds of other restraints. And it has been conducted very precisely. And we can see this, we can recognize this as a very good preparation for the visiting or the coming of the Mengtian module, the final module we made for this space station. And it will be probably launched next month. And it will also first dock to the front docking port and then transfer to the side berthing port. And at that moment, we can say that the T-shaped station has already been constructed.
Yeah, to understand how challenging this mission is, so how many countries now have this capability to do this orbit transposition mission?
Well, only Russia or the former Soviet Union have already done this before. U.S. That it do not have this technology because that's the the only third generation space station of the world is a Mir space station made by former Soviet Union and Russia before. For the International Space Station, that although it is more advanced and it belongs to a fourth generation, but it uses a different technology. The construction of the International Space Station, to a great extent, it depends on the capability, the powerful capability of the space shuttle.
Yeah.
So it also have another robotic arm called the Canadarm2. That on the space shuttle, it has a robotic arm called the Canadarm, and another one, bigger one, Canadarm2, on the International Space Station. With these two robotic arms, it do not have much difficulty in mounting different modules on the International Space Station.
Yeah.
So although we also use our robotic arm as a backup measure for this position transfer today. So we have the major measures using the position transfer mechanism, and we use the robotic arm as a backup measure so we can ensure the success of this important transfer. So we go one step closer to complete our construction of the Tiangong space station.